Hi, hello everyone. Now remaining two topics are there, that is Rolle's theorem and LMV theorem. Rolle's that is a mathematician name. What Rolle's is saying, that mathematician is saying, if you are throwing any particle at the maximum speed, the velocity is 0. At what point the maximum height is 0? That's we are finding here. Okay, now see what is Rolle's theorem. What Rolle's theorem is saying, let y equal to f of x is a real valued function defined on closed. Closed means including boundary. Closed interval AB such that fx is continuous on a comma b. Closed interval a comma b. What is continuous? Means this is start from a to b, it becomes continuous, that without break. That is called continuous, means LHL equal to RHL equal to f of x. Am I correct? Now fx is differentiable on open interval AB. This is open interval excluding boundary. Don't forget open or closed. Now third point, what they are saying, f of a equal to f of b. That means instead of x you have to keep a, instead of x you have to keep b. So f of a equal to f of b. Suppose if three conditions satisfied, then there exists a constant c. C belongs to open interval AB such that f dash of c equal to 0. That is Rolle's theorem. Okay. So now how we implemented this theorem in question. Now I am taking example one question. Suppose f of x equal to e power 1 minus x square, then x belongs to minus 1 to 1 closed interval. I am going to verify Rolle's theorem here. Now condition number 1, since this is exponential, already I told you exponential is continuous. Since fx is exponential function, fx is exponential function, therefore what? Therefore it is continuous, therefore it is continuous on closed interval minus 1 to 1. Number 2, fx is differentiable, fx is differentiable on where? Open interval minus 1 to 1. Step number 3, f of a. What is f of a? A is minus 1. Keep it minus 1. E power 1 minus 1 ka whole square, minus 1 ka whole square. Anyhow, anything power 0 becomes 1. Now I am finding f of 1, that is equal to again e power 1 minus 1, e power 0. So automatically f of a. So this implies we are getting f of minus 1 equal to what we are getting? F of 1. So three conditions are satisfied. Now then what I told you, then there exists a constant, then there exists a symbol is this, then there exists a constant c, c belongs to open interval, that is what is interval minus 1 to 1, such that f dash of c equal to 0. Am I correct? F dash of c equal to 0. What is f dash of c? First you find the f dash of x. What is f dash of x? F dash of x equal to ex differentiation is ex into differentiation of 1 minus x square minus 2x. Am I correct? So that is equal to, we are getting minus 2x into e power 1 minus x square. Therefore f dash of c equal to minus 2c into e power 1 minus c square. Now let f dash of c equal to 0. Am I correct? So this implies minus 2c into e power 1 minus c square is 0, but e power 1 minus c square is not equal to 0. So this implies c must be 0. So definitely 0 belongs to open interval minus 1 to 1. Open interval minus 1. This implies, or otherwise hence, a Rolle's theorem is verified. Rolle's theorem is verified when c is equal to 0. Clear to you? How to check this Rolle's theorem? So Rolle's theorem means you have to check first applicability, whether it is applicable or not. Then you have to go for finding value of constant c. That c must belongs to where? Open interval. Suppose if you are getting value of c is a 2 does not belongs to, then leave that 2, consider only 0. So Rolle's theorem is valid only when c must belongs to open interval. One more question let me take for this Rolle's theorem. So Rolle's theorem means you should remember the statement. That's keep in your mind. So Rolle's theorem, we are following 3-step as it is whatever theorem is saying. And then we need a little bit of differentiation. It is quite the easiest one. Now see another question I am taking example number 2. F of x equal to, the function is given sin power 4x plus cos power 4x. X belongs to closed interval 0 to pi by 2. Now, what first step is saying? Number one, fx is continuous. Am I correct? Why fx is? Since fx is a trigo function, fx is trigo function, क्योंकि trigonometry is continuous on its given domain, so therefore it is continuous. It is continuous on closed interval 0 to pi by 2. Now fx is differentiable. Am I correct? fx is differentiable on where? Open interval 0 to pi by 2. Now number 3, f of a, f of 0, sin 0. Sin 0 is how much? 0. Cos 0. Cos 0 is how much? 1. 1 power 4 is 1. That is equal to 1. Now f of pi by 2. So that is equal to sin pi by 2. Sin pi by 2 is how much? 1. Cos pi by 2 0. Now this implies f of 0 equal to what we are getting? F of pi by 2. Am I correct? 3 conditions are satisfied. Means Rolle's theorem is applicable. Now let us find the C. Now then there exists a constant C belongs to where? Open interval 0 to pi by 2, minded, such that f dash of c equal to 0. Am I correct? First you find f dash of x, then we will see f dash of c. F dash of x, that is equal to sine power 4 sine cube into differentiation of sine cos x. Now 4 cos cube, 4 cos cube into differentiation of cos, that is minus sine. Am I correct? Now simplify, bring this function into simplest form. Now 4 is common, sin x is common, cos x is common. Now we have sin square x minus cos square x. Take out the minus, you will get one formula. This 4, I am writing 2 into 2 sin x cos x, so that you can get a formula here also. Minus if I take it, it becomes cos square x minus sin square x. Am I correct? Now that is equal to minus, this becomes sin 2x, that is 2 into sin 2x. This becomes cos 2x. Am I correct? This for cos square minus sin square becomes cos 2x. That is equal to, again we have formula sin 4x. We brought into simplest form. Therefore f dash of c equal to minus sin 4c. Now let f dash of c equal to 0. Am I correct? So this implies sin 4c equal to 0. So 0 when we are getting, that is equal to sin 0, sin pi. Sin 180, sin 90 plus 90 becomes cos 90 becomes 0, sin pi, sin 2 pi, 3 pi, etc. Now this implies a 4c equal to, we are getting 0, pi, 2 pi, etc. This implies c is equal to 0, pi by 4, pi by 2, etc. But what is the given interval? 0 to pi by 2. So this implies only c is equal to pi by 4, which belongs to open interval. We are looking differentiability in the open interval. So this implies, hence, or otherwise hence, Rolle's theorem is verified. Rolle's theorem is valid or verified when c is equal to pi by 4, which belongs to open interval 0 to pi by 2. It is so quite easiest one. Simple differentiation we are using, and we are finding value of c. Are you clear about this Rolle's theorem? So one more mathematician, that is Lagrange mean value theorem. So what is the difference between both? Now let me explain. Now we are going to see, that is which one? Lagrange mean value theorem. Lagrange mean value theorem. Okay, that is we say simply LMV or otherwise mean value theorem, whatever they can ask you. Okay. So same, what he is saying, let y equal to f of x is a real valued function, a real valued function defined on same closed interval AB, defined on closed interval AB, such that number 1, fx is continuous, same fx is continuous on closed interval AB, or fx is differentiable, fx is differentiable on open interval AB. Now step number 3, this is a difference between Lagrange and Rolle's. Here what he is saying, f of a not equal to f of b. Rolle's f of a equal to f of b, and LMV is saying f of a not equal to f of b. So what is the difference? Then there exists a constant. C. C belongs to open interval say AB, such that what C is saying, f dash of C equal to f of B minus f of a the whole upon b minus a. So their Rolle's theorem, f of a equal to f of b. If we are doing minus, both are 0. That's why we said f dash of c equal to 0 in Rolle's theorem. So this is a statement of Lagrange-Rolle theorem. Means fx is continuous, fx is differentiable on open interval, and f of a not equal to f of b. After satisfying these three conditions, then there exists a constant c belongs to open interval a b, such that f dash of c equal to f of b minus f of a upon b minus c. Let us see some example of this LMV so that you will be clear how to use this statement in question. Now let me start one question. So first LMV I am taking, that is f of x is equal to sin x and then minus sin 2x. The interval is x belongs to closed interval 0 to pi. So now let us verify LMV here. Number one, since fx is a to-go function, fx is to-go function. So therefore it is continuous on its domain. On its domain means closed interval 0 to pi. Number two, fx is differentiable. Fx is differentiable on where? Open interval 0 to pi. Step number three, f of a, f of 0, sin 0 or minus again sin 0, this becomes 0. Now f of pi, that is equal to sin pi minus sin 2 pi. Sin pi is 0. This is LMV. I think f of x equal to, we are getting this, so this is not LMV. This is also we are getting 0. So we are sin 180, sin 90 plus 90, cos 90 becomes 0. Again sin 2 pi, this is also 0. We are getting f of 0 equal to f of pi. So means LMV is not applicable in this question. LMV is not applicable. We can go through. So if any one condition is failed, then we cannot go for this LMV. See what LMV is saying, f of a is not equal to f of b, but we are getting f of a equal to f of b. So here Rolle's theorem you can proceed, but LMV is not applicable. So let us take another example. I am taking one more example here. That is f of x equal to x cube plus x square minus 6x, x belongs to closed interval minus 1 to 4. Now anyhow, number one, since fx is polynomial, fx is which expression? Polynomial. So therefore it is continuous. It is continuous on closed interval minus 1 to 4. Number two, fx is differentiable. Fx is differentiable on where open interval minus 1 to 4. Now f of a, f of minus 1, that is equal to minus 1 ka cube plus minus 1 ka square plus 6. So minus 1 plus 1 and then plus 6, that is equal to 6. Now I am finding f of 4 ka cube 64 plus 16 minus 24. So what we will get it? So that is here 8, that is here, this becomes 24, 16 minus 24 minus 8. Minus 85 minus here minus 8, then we will get 52. Am I correct? Now f of a is not equal to f of b. Am I correct? So therefore, so then there exists so three conditions are satisfied. So we can move forward. Now then there exists a constant. C. C belongs to open interval minus 1 to 4, such that f dash of c equal to f of b minus f of a the whole upon b minus a. Am I correct? F of b minus f of a upon b minus a. Now let us find f of b and f of a, f of b and f of a. So that is, now see, now f dash of x I am finding. F dash of x equal to, that is differentiate this, 3x square plus 2x minus 6. Then f of b minus f of a, f of b minus f of a the whole upon b minus a. So that is equal to, what is f of b as per question? F of b is 52 or minus f of a. What is f of a? F of a is 6 the whole upon b minus a. What is b? 4 plus 1. So that is equal to 52 minus 6, that is 46 upon 5. 46 upon 5. Anyhow, now let us see, this is how much? That is 64. See, this is minus 6, I think 58. 56. I think this becomes 56. Yeah, it becomes 56. If you do calculation mistake, you will not get answer. That's keep in your mind. This becomes 56 and this becomes, if you do calculation mistake, you will not get answer. Okay. So calculation you have to take care. My duty is to clear concept. So you have to take care of your calculation. That's keep in your mind. So now as per question, f dash of c equal to f of b minus f of a, the whole upon b minus a. Am I correct? What is f dash of c? F dash of c is 3c square plus 2c minus 6, that is equal to this total function we are getting 10. Am I correct? That is 3c square plus 2c minus 16 equal to 0. This is how much we are getting. Multiplication is minus 48. Addition is how much? 2. So that is I think 6 8s are how much? 48. Am I correct? So what I am doing here, 6c square, 3c square plus 6c or minus 6c plus 8c. Am I correct? Minus 16 equal to 0. Multiplication is minus 48 and addition is plus 2. Am I correct? Now I am taking 3c is common, c minus 2, and then here I am taking 4 is common, c minus, here I am taking this, here I am taking 8 is common. Then c minus 2 equal to 0. So 3c plus 8 into c minus 2 equal to 0. So this implies c is equal to, we are getting minus 8 by 3 and c is equal to 2. But as per question, what is, this is 2 point something. Am I correct? Minus 2 point something. This is a 2. I think both value must belongs to where? Interval. So this implies c is equal to 2 comma minus 8 by 3. This is a 2 point something. Am I correct? I think 2 point something, so minus 1, 0, 1, 2, 3. So c is not equal to minus 8 by 3. Since minus 8 by 3 does not belongs to open interval minus 1 to 4. So this implies c is equal to only 2 which belongs to minus 1 to 4. So hence, are you clear? Hence, meanwhile LMV is verified. LMV is verified when c is equal to. So like this, see, nothing is difficult in Lagrange. Lagrange also saying you have to satisfy 3 conditions and calculation do it very properly. Then after that, don't forget this formula. Rolle's theorem we are saying f dash of c equal to 0, but LMV we are saying f dash of c equal to f of b minus f of a upon b minus a. That means you have to find left side and right side. Then see, this is left side and this is right side, and both I kept here equal. Then I am finding value of c. So don't forget the procedure for Rolle's theorem and Lagrange theorem. Anyhow, so today I am completing entirely differentiation topic. This is enough. See, differentiation topic, that's I told you. This is total 8 or 10 marks will come. So 4 plus 4. Maybe 1 question from continuity, 1 question from differentiation. Otherwise, maybe sometimes 2 questions, both questions are in continuity. So you have to prepare well. First cover up NCERT, then start to solve the paper. Thank you so much, children, and don't forget to subscribe my channel. Thank you.